For this last one, how many zeros do we expect to find? If we look at the highest exponent, we have 4, so we expect to find 4 zeros. Because remember, the degree always matches the number of zeros, or x-intercepts that we have. If we look at this graph, we have 4 zeros just like we thought. This time we're not given a factor or a zero. It says use the graphing calculator and then synthetic division to find 1 zero of f of x. So looking at this, we can pick any of these we want. So I'm going to start over here, and I see that this is x equals 3. So I'm going to say that the zero I found in my calculator is x equals 3. If you notice, I have x to the 4th, x cubed, x squared, x, but I don't have a constant. So let's start by putting 3 in our box. If I peel off the coefficients, I have 1, 2, negative 11, negative 12, and I'm missing a constant, so I need a placeholder of 0. If I bring down the 1, I have 1 times 3 is 3, 2 plus 3 is 5, 5 times 3 is 15, negative 11 plus 15 is 4, 4 times 3 is 12, negative 12 plus 12 is 0, 0 times 3 is 0, and we have a remainder of 0. So we know for a fact that x equals 3 is one of our zeros, and the corresponding factor is x minus 3. So then I see that I also have x equals 0. So let's continue to use synthetic division. So if I bring down the 1, I have 1 times 0 is 0, 5 plus 0 is 5, 5 times 0 is 0, 4 plus 0 is 4, 4 times 0 is 0, 0 plus 0 is 0. So we do get a remainder of 0. So now we know that x equals 0 is a solution, and our factor is x. So if we continue this over here, and we want to find the next one, if I look at the graph, I see I also have x equals negative 1. So I'll go ahead and put that in my box. And if we get remainders of 0, we know that it's a factor or a solution. So I'm going to just copy down what we had down below, 1, 5, 4. So bringing down the 1, we have 1 times negative 1 is negative 1. 5 minus 1 is 4. 4 times negative 1 is negative 4. And 4 minus 4 is 0. So now we know that x equals negative 1 is a solution, and x plus 1 is a factor. Lastly, if we look at our graph, we have x equals negative 4. So let's prove algebraically that that is also a 0. Bring down the 1. 1 times negative 4 is negative 4, and 4 minus 4 is 0. So we got a remainder of 0 again. So we have found our last solution, which is negative 4, and the corresponding factor is x plus 4. So we have 4 factors and 4 zeros, so we know we're done. Now, if we take a look at this, we started with an x to the 4th, then we have an x cubed, x squared, x, and then finally we're done. So to find all the zeros of a polynomial, we're going to start by looking at a graph. Then we're going to prove one of them using synthetic division. From there, you can continue to use synthetic division if the rest of your zeros are integer values. If not, and it's factorable, you can factor. And then, if you get it down to a quadratic, you can use the quadratic formula. Good luck on today's practice, and let us